Am I done?
Yes.
No. What did I say for vertical asymptotes? They make the bottom 0, but not the top 0. These numbers I've determined make the denominator 0. I need to plug them into the numerator. To ensure that they do not make the numerator 0. So I need to plug 5 halves in. 6 times negative 5 halves. What was it? Minus 2. Is that going to be 0? No, because I have another negative number minus 2. That's not 0. So I can just say not 0. That's enough. Do the same thing for 2 sevenths. I'll have 6 times 2 sevenths minus 2. Is 6 times 2 sevenths equal to 2? No, it's 12 over 7, so not quite 2. So this is also not 0. So now that I've checked that neither of these numbers makes my numerator 0, then these are my vertical asymptotes. X equals negative 5 halves, and x equals 2 sevenths. Asymptotes are lines, so you always have to write them as a linear equation. In this case, they're vertical lines, so they'll be x equals something, and x equals something else. Yes?
So is it pretty much always going to be the x-intercepts?
These weren't the x-intercepts. These were the two numbers you removed from your domain.
Oh, I mean the domain.
Not always. Because some of those domain things that you have to take out of your domain will make your numerator equal to 0, in which case they are vertical asymptotes. Okay? You will take them out of your domain, but then they're called holes if they make your numerator and denominator equal to 0 with the same degree. And holes are fun. Have you ever seen a hole? Yeah, it goes up, and then it's like it just skips over the line, and there's just a little blank hole right where the vertical line, that particular value is, and then it moves on. There's no going up or going down to infinity on the holes. But yes, your process is going to be the same as what you did in your domain question to find the domain, except that you have this extra little part to ensure that they're not holes as opposed to vertical asymptotes. Okay? Now, horizontal asymptotes. What do you think those are? There we go. It's a horizontal line, only one of them. You can have no more than one horizontal asymptote. But horizontal asymptotes are basically the end behavior of your rational function. So what you're talking about is as x approaches infinity, what does your function do? What? This is for the horizontal.
That's a limit.
We don't talk about limits.
Okay. The book does.
Yeah, the book does, but we're not mentioning limits. We're saying as x approaches infinity, what does my function do? Well, let's look at this. As x gets really, really big, looking at the thing in the numerator, what becomes important? Is this minus 2 going to matter? No, because it's not going to do equal is what? Is this 6x going to matter? Yeah, because it's 6 times whatever big thing I'm plugging in. So my numerator, the important part of my numerator becomes 6x. And the part that allows me to ignore the negative minus 2 is I'm telling you as x approaches infinity, as x gets really big, my function is getting close to looking like this thing. Now, what about my denominator? Well, let's look at this piece right here. What's important in this piece? The negative 2x. The minus 5 isn't going to mean much, right? So I'll have my negative 2x. And what's important in the second piece, the 7x minus 2? The 7x. So this is going to give me 6x over negative 14x squared. Yes? And then what? Can I cancel those x's out?
No, one of them.
Some of them.
The x
So
squared.
some people are saying no, and I know why you're saying that, because you were always told you're not allowed to cancel things that might be 0. Because you lose information that way. Are these gonna be anywhere close to zero?
No.
No, so that's what allows me to say, oh, I can just make this one and this one go away. So, because we're nowhere close to zero, we can cancel out one of the x's from the top and be left with 6, and one of the x's from the bottom and be left with negative 14x. As x gets really big, what is this getting close to?
Infinity.
0, because I've got a number over something really, really big. And when you divide a small number by something huge, you get very little, or 0. So I'm getting close to 0. So my horizontal asymptote will be the line that has the value, y value of 0. How do I write a horizontal line? Y equals, so this would be y equals 0. Now if this does not approach a value, a single number, then you would say there is no horizontal asymptote. In this case, we are approaching 0 because it's getting close to that. And so we can say that's it.
I was a problem with this stuff.
Now, your turn to do one. This one, you can skip the domain, the x-intercepts, the y-intercepts, and I want you to find the vertical and horizontal asymptotes. See, Addie?